doing the mechanics video for this week. So for this question, um, they gave us a VT graph and they want us to choose the object with a higher acceleration. Object 1 has a steeper line, so it means it has a greater value for the slope, and the slope in this case is the acceleration. So object 1 does have a greater acceleration than object 2. For this question, they want us to choose the equation that satisfies both of the following conditions. Condition 1 must be in the positive direction, and number 2, constant speed. Constant speed means URM, so it must be a linear equation. This equation is not linear, it's quadratic, and it means it's your URM. This one is linear, so we keep it for now. This one is not linear, so we eliminate it. It doesn't represent a constant speed. This one is linear, and this one too. Now, positive direction means that the t variable or the coefficient of the t variable must be positive. This one is negative, this one is positive since it's 1, and this one is negative, so we choose this one. Okay, for this question, it's a free fall question. So we state the four equations of UARM, I mean. V squared minus V initial squared is equal to 2A delta X. Then the other one is V is equal to AT plus V initial. We have X is equal to half AT squared plus V initial T plus X initial, and delta X is equal to V plus V initial over 2 times time. Now we need to specify the direction of motion. We consider it to be positive. Why? Because we are taught that when there's at least one stage of motion that is directed upwards, we consider the direction of motion to be positive, so directed upwards. When all of the motion is directed downwards, then we take the direction of motion to be downwards. But since here there's one stage it's upwards from A to B, then we take it to be upwards. Now, let's state all the givens. They said that the velocity vertically upwards is 12, so velocity will be positive. Then they give us a g, which is 10 meters per second squared, but we do it negative 10 meters per second squared because it's going downward and the direction of motion is upwards, so it's opposing, so it's negative. The time is 6, and we need to find out the height, delta x. The only equation out of these four which satisfies all of these givens or can fit all of these givens is this one. So let's copy it. X is equal to 1 over 2 g. Actually, let's modify it. So we do y is equal to 1 over 2 gt squared. It's not x, it's y now, like this. Plus v initial t plus y initial. So we do 1 over 2 times negative 10 times 6 squared plus 12 times 6 plus 0. Plug this into the calculator, you will get negative 108, but ignore the negative, you will get 108. For this question, they gave us two particles, P and Q, and they gave us the givens that P is from rest, has this acceleration, Q starts with an initial velocity and with this acceleration. They want us to find the time instant in which the two particles meet. When the two particles meet, that means that their position is equal. Okay? Now, the direction of motion is directed to the right like this. So it's positive here because they specified in the question A to B is positive, directed positively. That means that the acceleration of A will be positive 0.6 meters per second squared, but for particle Q, it will be negative 0.2 meters per second squared, and the velocity will be negative 4 meters per second. Now, the UARM rule that satisfies all of these givens is this one. X is equal to 1 over 2 AT squared plus V initial t plus X initial. Now we must plug in the values for both P and Q individually and take those two equations and make them equal to each other to find time. So 1 over 2 times, this is for P now, the position of P is equal to excuse me, times the acceleration 0.6 times t squared. V initial t is 0 since the starts from rest, and x initial is -7. Make it equal to 1 over 2 times -0.2 times t squared plus v initial t. V initial we made it was -4, so minus 4 t plus the x initial is 4. Now simplify this, you get 0.3 t squared minus 7 is equal to -0.1 t squared minus 4t plus 4. Minus 4t becomes plus 4, so let's continue here. 0. Move to the other side this one, so plus 0.1 t squared plus so it becomes 0.4 t squared plus 4t minus 4 minus 4, so we get -11 and make it equal to 0. You will get two values. A negative, when you do mod 5-3, you will get a negative value and you will get a positive value, which will be equal to 2.45. Neglect the negative value because time cannot be negative. For this question, let's see, it's loading. Okay, they want the acceleration between 0 and 2. This is 2 seconds here. Right here, like this, 2 seconds. And the coordinate here is 2, 4. 2, 4. And we have 0, 0. So let's do the slope to find the acceleration. 4 minus 0 over 2 minus 0. And you will get the acceleration is 2 meters per second squared. Now, the net displacement of the object. It's a VT graph. That means that the net displacement is equal to the area under the graph. And it's a trapezoid. So the rule for the area of a trapezoid is base 1 plus base 2 over 2 times height. Base 1 here is 10 plus base 2. Here we have 2 and 6. So 6 minus 2 will be 4. Over 2 times the height, like this, will be 4. So 14 over 2 times 4. So 7 times 4, and you will get 28 meters. For this question, okay, many of my friends, my classmates, and even I, we get confused between the rules URM, and these rules. So for this question, I'll try to do it a bit differently. I'll try to do it graphically, so we can explore the other concepts, the other ways that we can do questions. So I'll do this question graphically, just in case you get confused between the UARM or URM rules. I'll do it graphically, like here. We draw a VT graph. So we have 5, 10, 15, 20, and 25. And we have 5, 10, 15, 20, and 25. Let's start from 5 to 25 in 10 seconds, like this here. And then travel still at 25 for another 10 seconds. So a constant velocity and at rest. Okay, now let's do it like here, like this. Let's draw on the imaginary line, and we can see that we have a polygon. They want the total distance, the area under the graph. But you don't know the rule for the area under graph because it's not a trapezoid, it's a 5-sided polygon. You have 1, 2, 3, 4, 5. So we can divide it into 2. A trapezoid and a rectangle. The rule for the trapezoid is base 1 plus base 2 over 2 times height, and for the rectangle, not triangle, I think I said triangle, my bad, I mean rectangle, it's length times width. Okay, so base 1 here, it's, let me use another color, it's 25, like this is base 1, 25 plus base 2, which is 5 over 2 times the height is 10 times add it to the length, which is 25 times the width, which is 20 minus 10, so 10. Add this and you will get 400. Okay, so for this question, we have missing numbers. The most important missing thing here is velocity. They gave us acceleration, they gave us time, here they gave us time, and they gave us acceleration. Why do we need the velocity? It's because here it says it runs at a constant speed. How can you know this constant speed? By finding the speed here. The reason for this is because a constant speed means it's a continuation of this stage. Okay, I'll show you how. Let's find the velocity here. We can use rule v is equal to at plus v initial, the simplest one. V, which we need to find, is equal to the acceleration 2 times the time plus v initial is 0 because it's from rest. That means that the velocity is equal to 20 meters per second. It's at the constant speed, so the speed is 20 meters per second throughout the whole stage since it's constant. Then it slows down at negative 4 meters per second squared. That means that the initial velocity will be 20. So it's something like this. Look how. So here it's 20. Here it's 20. Actually, here it's 0. And here it's 20 meters per second. The whole thing here 20 meters per second. Here it will be 20 meters per second. And here it will be 0 again. Okay? So, they want the distance. Let's use the rule for the distance for stage 1 here. Excuse me. We can use x is equal to 1 over 2 times 2. We use the rule 1 over 2 at squared plus v initial t plus x initial 2 times 10 squared plus v initial is 0 t plus 0 as x initial, since it starts from the origin. And we get it as 100 meters. So for the first stage, we have 100 meters. This one is like the other question. You can do it graphically or you can do it like this. Okay, I'm just showing you two ways of solving the question. For this one, constant speed for 30 seconds. The speed is 20 meters per second. Here, we don't use UARM, we use URM. So x is equal to Vt plus x initial. X initial 0, x we need to find it. What's the velocity? 20 times the time 30, so it will be 600 plus the last stage. They want us to find the distance, and we have velocity and acceleration. Velocity, acceleration. And what is the distance? Do we have time? No. Can we find time? Yes, we can. But if we want to find time, we need to plug it into an equation and plug the answer of this equation, the time, into another equation. We're using two different equations. That is time consuming. So instead of doing that, the two equations that we will use is this one, so the first one. And the second one will be, if I'm not mistaken, it will be v plus v initial over 2 times time. It will be this one. It's time consuming. So instead you can use this rule. You have v squared minus v initial is equal to 2a delta x. Just one step. What's the v final? It's 0. It comes to a rest. Minus v initial squared is 20 squared, which is 400, is equal to 2 times. What's the acceleration? Negative 4. And then delta x, we need to find it. So negative 400 is equal to, here delta x, negative 400 is equal to negative 8 delta x. And you get delta x is equal to 50. Because like 400 over 8, the negative will cancel and you get 50. So plus 50. So 100 plus 60 plus 50 will get you 750. Okay, the duration of phase 1 of the car's motion is 6 seconds. Okay, for this one we use UARM, we use v is equal to at plus v initial. The final velocity is 18 is equal to the acceleration 3 times t plus v initial 0. So 3 times that will be 18, 6, so 6 seconds. Distance traveled in phase 1. We can use many rules. we can use x is equal to half at squared plus v initial t plus x initial, since from starting from like rest, this all cancels out. So 1 over 2 times acceleration, which is 3, times t squared, so 6 squared, and you will get 54 on the calculator. The total duration of the car's motion, so the duration here and here and here, let's find it. Here they gave us 9 seconds, so we have 9 plus. Here stage 1 is 6. Let's find for stage 2. We can do URM equation. So like x is equal to vt plus x initial. X, which is 360, is equal to v18t plus x initial 0. So 360 over 18 will get you 20. And 20 plus 9 plus 6 will get you 35. The total distance traveled by the car. Okay. To the total distance, okay, we have the distance in phase 1 here, 54, plus the distance in phase 2 here, 360. Let's find for phase 3. We have decelerates like this, UARM, I don't know what, like this, like this. What you can do is let's try x is equal to 1 over 2, or delta x, 1 over 2 at squared plus v initial t. We don't put plus x initial since we moved it here. Okay, half of the acceleration, we need to find it. The time is given, the initial velocity also, you have to get it, although it's here 18. Okay, so here you have two unknown, the displacement and acceleration. Therefore we cannot use this equation, so let's use another one. So first we use the rule v is equal to at plus v initial. V final is 0, v initial is 18. The acceleration we need to find, the time is 9, so 9a plus 18 is equal to 0. What will the acceleration be? It will be -2. Now that we have the acceleration, then we can use x is equal to half at squared. So x is equal to 1 over 2 times -2 times 9 squared plus v initial, which is 18, times 9 plus x initial 0. So now we plug this into the calculator and we get 81. So we have 81 for phase 3. Add these all up and we will get 495. Okay, for this question, a particle moves along a straight line. They give us the equation, so they want the displacement between particles. So we do x of 3 minus x of 0. X of 3, we substitute 3 in this equation. You will get, so 3 squared plus 3 minus 5. You will get 40. So 40 for x3. When you substitute 0 in here, you will get -5. So minus -5. So it will be positive, so you get 45. The average velocity, they want average velocity. Average velocity will be x of t 1 minus 2 actually, minus x of t 2 over t2 minus t1. So basically it's these values. So x of t2 minus x of t1, x of 3 minus x of 0, we got 45 over 3 minus 0, and we got 45 over 3, and we get 15. Now they want the velocity at one specific point. At one specific point means instantaneous velocity. To get instantaneous velocity, we derive the equation for the position or the displacement or the distance, the displacement. So let's derive this one. We get 8t plus 3. Okay, and we will get this equation. We substitute 2 in it, so 8 times 2 plus 3, so 16 plus 3, and we get 19. Now they want the acceleration at any instant. The acceleration at any instant we got for the velocity 8t plus 3. So we derive again to get the acceleration, the velocity. To go to acceleration, we derive again, we get 8. Or 8.0 for 2 sig fig. Okay. For this question, we have a car, but let's actually draw the line. Let's draw it something like this. And we have here the gas station, and we have a car going away from it at 60 kilometers per hour. And we have a motorcycle at 500 meters, X initial for the motorcycle. It's moving like this at 40 kilometers per hour. But obviously, it will be negative 40 kilometers per hour since it's moving in the opposite direction. We take the car to be the direction the car is going in, the positive direction. So now they want the time elapsed when they pass each other. So they want the time instant when the position of both the car and the motorcycle are equal, and they want then the motorcycle passes the... Okay, so then we'll see how to solve part B. For part A, what can we notice from the answers? They're asking it for us in seconds and in meters. However, they gave it to us in kilometers and in hours. So it's better that before we solve anything, we convert the givens into meters per seconds. How to go from kilometers per hour into meters per second? We divide by 3.6. So on the calculator, divide 60 by 3.6. 60 divided by 3.6, and you will get 50 over 3. So 50 over 3. And for 40, divide by 3.6, and you will get 100 over 9 meters per second, meters per second. Now that you have successfully converted them into meters, we must find equations of this one that have both velocity and time and make them equal to each other so that we can find the x. Basically, we're using URM here. So x is equal to Vt plus x initial. So the x's must be equal to each other. So Vt plus x initial must be equal to Vt plus x initial. Let's do the car first. The V will be 50 over 3 times t plus x initial 0, since at the gas station we took it to be 0. And here Vt, so the velocity will now be negative 100 over 9 t plus 500. We took it to be like this. Okay, so 50 t over 3. So now we find t. Plug it into the calculator, as I said, and you will get t is equal to 18. Okay? Now, what you do is they want the motorcycle passes the car how many meters away from the gas station? So what you do now that you have the time, plug in the time into either equation. The easiest equation that we had was x is equal to 50 t over 3. So substitute t by 18, and you will get here 50 times 6, and 50 times 6 will get you 300. For this question, they want the displacement, so the area under the graph. The area under the graph here and under here. We have a triangle and a trapezoid. The triangle is base times height over 2. The base is 4 times the height, which is 6, over 2, plus. Now the area of the trapezoid, okay, so 4 times 6 over 2. Area of the trapezoid will be, the first base is 12 to 4, so 8, so 12 minus 4, and the second base is from 8 to 10, so 2, over 2 times the height. This will be here, negative 6. Don't forget the negative, it's negative. You're using displacement, so don't forget the negative. Plug it into the calculator and you will get negative 18. Okay. They want the displacement of the block. We have acceleration, we have this, so we use UARM. The most obvious rule when we see all of these variables, we have four things we need to know. We use the longest one, x is equal to 1 over 2 at squared plus v initial t plus x initial. That's the acceleration. It's 4, but it's decelerating, so negative 4. What's the time? 6 squared. What's the v initial? So 20 times 6 plus x initial is 0. Plug this into the calculator and you will get 48. For this question, they want the distance covered by the plane and the time needed for the airplane to reach 30 meters per second speed. And they give us that the Boeing 747 is an airplane that accelerates from rest to 80 meters per second at a rate of 2.5 meters per second squared. The distance covered, we can do x is equal to 1 over 2 at squared plus v initial t plus x initial. The acceleration here is 2.5. What's the time? We don't know. And what's the v initial here? It's 0 and like this. So we can notice there's actually a missing variable here and we have a missing variable here. So we have two missing variables. Therefore, we need to use an equation of UARM that does not have time, which is this one. V squared minus V initial squared is equal to 2ax. That's why in question 3 or question 4, I said always write the UARM equations on the scratch paper so you can see them. Me, I did not write them because I'm explaining fast for you guys. But since in the exam you can be a bit more relaxed to write the... You'll be stressed in the exam, obviously, but you can move at your own pace. So write the own rules. So v squared, so it's the final, at squared, minus v initial squared, 0 squared, is equal to 2 times the acceleration, which is 2.5, times the displacement. Plug this into the calculator, and you will get delta x is equal to 1280. Now for part B, there's something wrong with the question. It gives you the wrong answer. So actually, if you want to reach the 30 meters per second speed, you will get an answer of 12. How do you get an answer of 32 meters per second is if you use 80 meters per second. So this question, it's a wrong question. Okay? So don't do it. However, I will tell you how to do it, and how to get 12. And if it's 30, I'll tell you how to do 12. So how you do it is you do the UARM equation. V is equal to AT plus V initial. That's all what you need. The final velocity, it's given to us 30. Okay. The acceleration here, they gave it to us 2.5. T, what we need to find, and V initial here we consider it as rest. So T here will actually get us 12 seconds, okay, not 32. The total displacement for this question is the area under the graph, so the base times height over 2, it's a triangle, so the base, which is 80, times the height, which is 6, over 2, and this will get you to 40. The displacement of the runner in these 10 seconds. They gave us velocity, they gave us acceleration, they gave us time, they want us to know displacement, so we use this long rule. X is equal to 1 over 2 times the acceleration, 0.5 times 10 squared, plus v initial t, so 1 times 10 plus x initial, 0. So plus 10, and plug it into the calculator and you will get 35. For this question, they gave us a graph, an h t squared, so it's يعني it's different. Okay, usually it's gonna be meters per second here, and here is second down, but no, they grouped the seconds by themselves and the meters by themselves. They want us, what is the value of the free fall value of acceleration? Okay, one of the rules for UARM that we use is x is equal to half a t squared plus v initial t plus x initial. The modified version for free fall is y is equal to half gt squared plus v initial t plus y. Here v initial t is 0 since it starts from rest, and y initial will be also 0. So this is all like this. So the new equation that we have is y is equal to half gt squared. Y in this case, we put it as h, okay, since the y-axis is h for this question. So we have this. Y is equal to half gt squared. Now, watch what I'm about to do. We can rearrange this rule. How to rearrange it? What is the slope of this line? The slope of this. The graph represents an h versus t squared. So an h versus t squared. Versus يعني basically divided by t squared, right? يعني the slope will be the change of the height over the change of t squared. Okay, please stay with me. The change of the height over the change of t squared. Okay, this is equal to the slope of the graph. So if we divide by t squared on both sides, we will get h over t squared. And we said that h over t squared is the slope. And the slope is equal to g over 2. And they want the free fall acceleration. And they want g in this case. Okay? So let's multiply by 2 on both sides, and we get that double the slope will be g. So let's find the slope multiplied by 2, and we get the answer. Okay, let's find 2 points in this graph. We have here 0, 0, and we have here the intersection here. If we line it up here, we have 1 as the y, so 1. But what about the x? Let's look in here like this. Here we have it. Now, let's evaluate each box. 0.15 starts from here. How many boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 boxes, okay? How to find the value of each box? This is what we do. We take the final value minus the initial value. Final value minus initial value over the number of boxes. Okay, this is a logical thing to do. So what's the final number? 0.2 minus 0.15. 0.2 minus 0.15 will be 0.05. Sorry, not 0.2 minus 0.1. Sorry guys, my math is not mathing. I'm a bit lost. Yes, it is 0.05. And we have 10 boxes, so we divide 0.05 by 10 and we get 0.005. So يعني one box is equal to 0.005. Let's count how many boxes away from 0.2 is this. 1, 2, 3, 4, 5. So we do 0.005 times 5. So times 5, and we get 0.025. So this value here like this is 0.025. Added to 0.25, so plus 0. Sorry, added to 0.2, and we get that this value right here is 0.225. So يعني here this one is 0.0 or 0.225 like this. Find the slope of this. 1 over 0 minus 1 over 0 minus 1 over 0 minus 2, 0 minus 0.225, and you get that it's 225, and you get the slope is equal to approximately 4.44 repeated. Now we got the slope 4.4 repeated. Multiply it by 2, you get 8.89 يعني 8.888 repeated يعني 8.89 and it's up gonna be you have in the options you don't have 8.89 so it's gonna be approximately equal to 9. This is the last question okay, this is an easy question. What is the gravitational acceleration near the surface of the Earth? 9.81. These questions are repetitions of previous questions in the quiz, so we don't need to do them. Thank you guys and good luck for tomorrow.